explain about fault currents in a motor, the path taken by the fault current, and the calculation of the fault current. When a fault takes place in a motor terminal box, you can see the current takes three paths. One, it flows through the earthing conductor IF1. The second current IF2 flows through the cable armor and the tray. The third path of current flows from the concrete foundation and the earth back to the source. So these are the three different paths, IF1, IF2 and IF3. This is about the fault current path. Now I'll explain about the calculation of the fault current. So to calculate the fault current, very simple, just write down a circuit like this and write down the impedance of all the equipment like transformer, cables. Then you add those impedance, you can determine the fault level. Here we have determined that the fault current is 4.8 kA and the fault current flow from the motor via the earthing conductor will be the highest because that impedance will be very less. So this is just wild, that's not a calculation, maybe approximately 4 kVA, and the fault current through the armor may be 0.7 kVA, and the fault current that is flowing from the foundation to the earth may be around 100 amps. This calculation is not required, it is just for illustration, but you need to calculate this fault current 4.8 kVA. The reason why you need to calculate this current is to size the earthing conductor. Now, based on the short circuit calculation, the cable here is a 50 mm square cable, so its impedance is 0.8 milliohms per meter. So this is a 50 meter cable, so the total impedance will be around 0.8 into 50, that is 0.04 ohms. So we convert it into per unit impedance, we get it as 12.5%. The cable is 12.5%, the transformer is 4%, so total impedance from the source up to the motor terminal is 16.5%. So we get the, finally we do all this fault calculation using per unit method. I will not go more deep into the method here. So we get the fault current as 4.8 kV. So for a 22 kilowatt motor, the owner may be recommending a 25 square mm cable for earthing. But since this motor is very close to the switchgear, 50 meters, the fault level is high. So for a 4.8 kA for 1 second fault, so you have to use a cable of 35 or 50 mm square. See one thing, the fault will be cleared in 100 milliseconds, but still when you size the earthing conductor, you have to size it for 1 second, not for 100 milliseconds. So we need to use a conductor which can carry 4.8 kA for 1 second. So you can use either 35 mm square or 50 square mm copper cable.